Then, let's get this. Hmm. Okay, good. We could start there. All right, so let's start with. Okay, we left off with your starting second problem or second math function. I think I actually messed it up. So which one? Signs. Can you guys tell me what I wrote? And I'm gonna switch. So I'm gonna switch the signs so that we can kind of do everything that I want. So we're 2x minus 3 plus the minus all. What I need to change here is so I think what I needed to change that this should I wanted this to be 2x squared plus x squared. Right. So what we're gonna do is we're gonna take this kind of pull through. So at the end of Tuesday, let's talk about we can figure a bunch of stuff out about the graph without even touching a table. So we're still going to need a table, but what we saw on Tuesday is to graph something like this, you end up with a really expansive table. It takes probably 10 minutes put together. And so instead of that, we can do some work to begin with to figure out a lot of, that's of that graph that we figure out in table things. But we can figure out x-intercepts, we can figure out vertical asymptotes. On this one, we'll talk about the pole in the graph. We can figure all that out, y-intercepts, horizontal asymptotes, we can figure all that out before we even touch the graph itself, or try to build tables or do any of that. So that's the approach I'm gonna take on this today. We're gonna figure all that out first, put it on a graph, and see, kind of the least number of x values we can figure out. So so the first thing we need to do in order to figure out x-intercepts or asymptote and talk about the whole graph. What did we talk about right at the end of class? Let's say, what do you need to do to figure those? You just said the top and bottom of the fraction equal to 0. Figure out basically what x values make the top 0, what x values make the bottom 0. And then those will tell me x-intercept, vertical asymptotes, and the whole thing. We didn't do the whole graph last time, it's just in that previous function, we'll have it here. But that's the first thing I want you guys to do, is I want you to set the top and bottom equal to 0 and solve them to figure out what makes the top and bottom equal to 0, and then tell me the x-intercepts and the vertical asymptotes. So I'll give you all whatever, like 5 minutes or so. In particular mix of y'all that we have, let me put some music on. I think this will actually work well. Hmm. Mm. 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 Only the time. Wants a new past. All right, so I do see a lot of y'all as standstill. So we're setting top and bottom equal to 0. The first thing is to kind of figure out what to do with this. So I was talking in the last class about, I will say one thing about like these problems that you end up doing with rational functions. Rational function problems, I would say, are definitely the longest and hardest problems that you have all of them. And part of the reason is like there is no set path for these problems. This is the type of problem that you get a lot of higher mathematics and engineering and science where by the nature of it is you never write a procedure for it. What you have to do is as you kind of set yourself up to go through the problem, like in this case, we set it equal to 0, you then, from what you know about algebra, you decide what that next step is going to be to go through the problem. And so, for instance, we set these equal to 0. The first thing then you're asking yourself is, how do I solve that equation? And solving is one or two, getting x by itself at that. And so looking at the top, what did you guys decide itself at that? Um, let's go ahead for the bottom two. Is that gonna be X slash L or that gonna be factor? So that's the first thing you do is you tell yourself, you decide for yourself that it's factored. And once you know it's factoring, you gotta go back to, okay, if I'm self, I'm gonna factor. Then I've gotta, let's check out, one second. First thing on the check down list is the check for common factors. And so for either of these, do you guys see common factors?
See, I mean, I know what the factor is. I know.
Well, I mean, like, is there one thing you can divide out of all three pieces, top or bottom? Go with your instinct. Yeah, like for instance, on the top, is there one thing you can divide out of every?
So, and but if we divide something by one, does it change it? It's, so,
Yeah.
but the thing is that is,
Yeah.
You could also,
yeah, you can always divide by one. We just know that if we divide by one, we don't change it, so it doesn't advance us. It doesn't cheat it. Um, I don't, good, so neither of them have a common factor, but that is the first thing you wanna check for. So the thing is, I do wanna get you guys out of the habit of always going to parentheses first, because you're not gonna see that either in the homework or on the test. On a test, honestly, I try to, like, part of what I do on a test when I write a test is I try to like catch a broad amount of skills that you guys have picked up in the class. But one of our skills was factoring out a common factor. So we may not see it here today, but you will see it in the homework. You're gonna have to also factor out a common factor. So not just the two parentheses. So the first thing you should check for is a common factor, but if that doesn't work, then you want to try to factor two parentheses, both of these. So we're gonna try to factor both of these into two parentheses.
This is where, so I wasn't sure how far you guys got on this. How does the top of that?
X minus three, X plus one.
So that'll be X minus three, X plus one. And again, this is gonna be the part of the problem where, I mean, you know, so earlier in the semester, we just had problems that said, hey, factors. Now, hey, factor, this thing is embedded as literally 1/8 of a much larger problem. And again, that is just the nature of this. So some of the last class, you also have to be easy on yourself. Like, this is gonna be a long problem with a lot of small parts. Where you gotta remember how to do some problem that we did week 3 of class that gets embedded into the larger problem. And that is just how it is. So have fun with it, but also be, it is a longer, harder problem. A lot of things. Plus. That's. So, so it'll take you a second to work on that. That's what it should be, so be easy, so. The same with the bottom, it's gonna take you a second to work out that factor, but what would you get back? Yes. You'll get 2x minus 1 times x plus 1. Good. So to solve these, we know we have the factor, we've got our factors now we're gonna get our factors equal to 0. Look at the top, when we set those equal to 0 and solve, what is it? Positive 3. So that's to give you positive 3 and negative 1. And what about 5? X will equal 1/2. X will equal negative. Once we have all that, Yeah, what we talked about last time, is the first thing to think, the first category or thing you wanna think about is have zero divided by something. Whatever that something was. As long as that something's not zero, this gives you zero. So what that's telling us is whatever makes the top of the fraction zero should give me an x-intercept. There was a second thing we considered that we have something divided by zero, that doesn't, that's an impossible calculation, does not exist. So this gives us x-intercepts. But does not exist, what does that give us about the graph? Vertical asymptotes. The vertical asymptotes came, so physically last time on Tuesday, when you got a calculation that said that does not exist, divided by zero. That turned out to be a vertical asymptote graph. So it looks like whatever makes the bottom of the fraction zero then gives vertical asymptotes. And then the third situation that we talked about, which we see in the problem on Tuesday, is that if I have zero divided by zero, well, there's something that makes both the top and bottom of the fraction equal to zero, same as side of six. Zero divided by zero gives me not either of those results, it gives me different results. Calculation that's indeterminate. So basically, I think the one you guys said, which was really good, is everything else. Zero times anything. Which means I don't really know what the y is, because it could be anything I want. And then what I told you guys is that this gives you a whole graph. So on this one, now that we know what makes the top and the bottom of the fraction with a zero, we can fill out all three of these. So for the x-intercept, so give me what makes, from what we figured out, what makes the top of the fraction zero, but just the top of the fraction, not the bottom. What makes the top of the fraction zero? 3 and, yeah, 3 and negative. Now notice the negative one also makes the bottom of the fraction zero. So yeah, so that's going to be a whole rather than an x-intercept. But the x-intercept then is going to be and then what makes the bottom of the fraction equal to zero? Yes, I am. Yeah. And negative one. But again, the negative one also makes the top zero. Yeah. So negative one, and we'll talk about how you get the y value for that, but that's going to be the whole. But the vertical asymptote then is just the x equals 1. Now let's look at what we kind of do with both. So we know that x equals -1, then it's giving us a whole. Both top and the bottom of the bracket is 0 the same. So my hole in the graph, so when I say hole, I mean an open circle. And when we even had a problem or two as a second or third week class like a second week, we had the open circle. But we needed to know how to graph it, right? So an open circle means the graph, it's like literally a board, a black hole in the line. So your graph somehow just skips over that. But we still need to know where it skips over. We need to know the x value to the y. For those. So notice that we have the x value. So my polar graph has an x value of -1. And if I know the x value, how would I normally get the y value for any? You plug it in. Now the problem with this that you're going to see though is when you plug it in, you're going to get 0 over 0, which is indeterminate, which we don't know what the y value. So legitimate question is what in the world do I do? Like, how do I get to that? What do I do with this? what I wanna do really quick. Get y'all to see, kind of make the connection with what's in here.
So I wanna rewrite g of x. This g of x. G of x. But g of x, we, instead of writing it using this top and bottom, since we factored top and bottom, we could rewrite g of x using the factors. So we just call this factor. So you can rewrite it with the factors rather than the next square minus square plus 3, etc. So we know that they multiply out. So they're the same. I write g of x as x minus 3 times x plus 1 on top. So those are my factors. And then 2x minus 1 times x plus 1 on the bottom. So this is the same sheet. I'm just addressing different books. And from here, by the way, it becomes big, again, it becomes easy to see why we're getting the 0 over 0. We're getting the 0 over 0 because when I plug in -1 to this, notice -1 plus 1, where's that? And then 0 times anything, and now it doesn't even matter what this 0 times anything is 0. And -1 plus 1, so again 0. 0 times anything. So we're getting the 0 over 0 because of this fact. So basically, if I didn't have this factor, then I could plug -1 in and get a y value. But I'm getting 0 over 0 because of this fact. Now, think about simplifying fractions. When you simplify a fraction, you cancel out a common factor. So like if I have something like 25 over 15, I can simplify this 5/3 because I can divide it by. And these have the same value, they're the same fraction. This one we call simplest form, just factored away common factor. What do you all see here? What common factor can I divide out? X plus 1. So the clever thing about this is that I can simplify this just like I do any other fraction and get rid of my common factor. And once I do that, that resolves my issue of plugging in the -1 and getting 0 over 0. Now I can plug in -1, actually get a y value. Now g of x is going to be x minus 3 over 2x minus 1. And now let's plug in -1 and see what we get for the y value. So just do that. Take a second to do that. Yeah, question.
Sorry.
Okay. Yeah, that's no worries.
Oh, yeah, email your brief.
Yeah,
Says call is over.
it's okay. No, yeah, in general too, like once I'm in the middle of classes, I never see my emails or my messages, so that's no worries.
Thing.
Right, so when y'all plug in -1 now to the simplest form or the reduced form here, what did you get for y? Yeah, 4/3, perfect, yes. It's gonna be -4 over -3, which is just 4/3. So that hole in the graph is gonna be at -1, 4/3. Now I can write that open circle. Not 3. So setting the top and bottom equal to 0 gets you these 3 things about the graph. So it's to start the. So let's just start getting a picture of what we got there.
Alright, so what I have so far is I have x-intercepts at 3, 0. I have a vertical asymptote at x equals 1/2. All vertical asymptote right through here. And then we have a hole in the graph at -1, 1/3. -1, 1 and 1/3, I'm gonna write it over soon. So my graph is gonna go, again, through that point, just skip that point. So notice that a lot of those things that we figured out on Tuesday, kind of painstakingly by plugging in a bunch of x values and finding does not exist, etc. This is, again, an alternative way. So I'm not saying this is, like I've always say with graphing, if you want to get the graph going by just plugging in a bunch of x values, it works perfectly fine. You'll do more work in the end, but actually that's, as long as you're fine with that, it gets you the whole thing. But a lot of those things that we found, we've worked on. Got an intercept, so I show that. A couple other things that we figured out about the graph. That we can figure out about the graph without plugging anything in. So y-intercepts. So not just this graph, but any function. How do I find one? Set x equals 0. So y-intercept is always 0, comma, something. So we're going to go back to our original, the original function, and we're going to plug in 0. So this honestly is the same and as easy as it always is. 2 times 0 squared plus 0 minus 1. Well, what are we going to get on top? Another fraction. -3. On the bottom. So what's that going to be? 3 more. So my y-intercept is 0. And I'll go ahead and mark that too. So 0. 3. Notice that I'm starting to have a decent idea what the left side of this graph looks like. So the graph that we looked at on Tuesdays had 3 parts. Notice that because this one only has 1 vertical asymptote, this graph kind of naturally just has 2 parts. There's the left side and the right side. The last thing we figured out on our graph on Tuesday was what's called a horizontal asymptote. And so the one on Tuesday, so remember the one on Tuesday, the largest power on the bottom was bigger than the largest power on the top. So he actually brought up a good way to think about that is it's bottom heavy. And if it's bottom heavy, if the power on the bottom is larger than the power on the top, then what was our horizontal asymptote on it? It was 0. So y equals 0. Notice here that we don't have that though. So how did the largest power on the top and the bottom compare here? They're the same. They're the same. So now we want to talk about what happens to the horizontal asymptote if the largest power is the same top. Because part of what's happening if they're the same, so again, the value of your fraction overall when you plug in large negatives and large positives is governed by the largest power. So now what's happening, if the powers match, that means in some sense the top is keeping pace with the bottom. Except for, notice the coefficients. So the largest power top is x squared, the largest power bottom is an x squared, but it's a 2x squared. So whatever we plug in on top is always going to be half of what we end up with on the bottom, or roughly half. The bottom is 2x squared and the top is 1x squared. Does that at least make sense? So it ends up, if your powers match, then all you got to do basically is look at your largest power top and bottom.
And then just simplify the coefficients. That actually tells you your horizontal asymptote. So what I mean there is, abbreviate this with J with horizontal asymptote. So the horizontal asymptote then is going to end up being pretty much what we do is if the powers match, you write those leading terms, and you just simplify this. And if you simplify this, what do you end up? It's 1/2. So the x squareds cancel out, and you end up with 1/2. So what this says is again, on the ends of our graph, so far right, far left, big positive x values, big negative x values. The overall value that you get out of this fraction is going to be closer and closer now, not to 0, but to 1/2. So we are going to have a horizontal asymptote now, not on the x-axis, but up, just a little up at y equals 1/2. And you would see this. So if you plugged in a 10 and a -10, and you plugged in a 50 and a -50, those fractions would not be 1/2. They would be close, and they would get closer as you plug in larger and larger. Yeah. So if the horizontal asymptote is like 3 or 4, then you literally, you go, let's say it was at 4. Then you would draw a horizontal line through y equals.
So it's very easy to see.
Okay.
Once, but if we were to do like problem.
Yeah.
You know, like if I were to do that, like if stop,
Yeah.
you know, how I would turn that.
Let me show you an example. Yeah, okay. I see what you're thinking. So let me show you an example. So let's say your h of x is, so this probably won't be factorable, but I'll just make up some numbers. Something like this. Then let's say the bottom was something like this. And you wanted the horizontal asymptote like this. So again, for the horizontal asymptote, you're going to look at your leading terms. And since the powers match, horizontal asymptote here is going to be, you're just going to basically take those leading terms and simplify. So that would be 2. So it ends up just being, since these match, these always cancel out. So it really just ends up being the coefficients. Then you take the coefficients of the fraction and simplify. Yeah. Yeah.
As you said, very possible. Are we not living negative, but it's a bit possible? It's like consistent.
It exists in both top and bottom, yeah. So good question. So if it exists in both top and bottom, it gives you a whole which is separate. Whole is, even physically, what I've, not just, but I mean, what I've done on the graph, a whole is an open circle. Vertical asymptote is an invisible vertical. So it's like physically they're different. So you can't count one as the other. Yeah. We're essentially gonna go around the hole. Technically what you do is you go through it, you just don't draw the line actually in the hole. So you're showing the reader that it gets close to that point, but it never actually reaches it. So think of it like a black hole. Like in a black hole, that points in the map of our universe doesn't actually exist, right? To this infinitely exists. So you never really get to that. Does that make sense? Or I don't know how much you know about the cosmology and stuff like that. But yeah.
Can't go through it.
Yeah, you can't go through it, but yeah. But yeah.
What is the point of?
Well,
I don't have one.
there's a lot of natural phenomena, especially in physics and chemistry, where there's just literally there's a certain value that you plug into the experiment that doesn't work.
It's kind of like maybe we're on grass. some of them have circle or.
Yeah, yes, it's exactly that.
But that helps me understand it, because at
Yeah.
that time, just like you said, it never actually.
It never reached so, yeah. But I mean, so that is what's happened, never actually reached that.
But it reaches after it.
Yes, they were after and before, so it's, you almost think of it as a line coming two different ways. So coming from the right, it's coming towards that point, but it never reaches it, and from the left, it comes to that point, but never reaches it. So there's action from both sides. The graphs we saw in the beginning of the class, it was only ever one direction. It would just come from the left or it just come from the right. But it's possible to have action from both directions, and that's just there's a point in the middle that it never gets.
Kind of like it's in the way.
Yes, it is kind of. I almost think about it like, if you think about the universe as like a, like it's a rubber, so some fabric, it's literally like you're poking a hole. So if you had some little ball rolling, on a, but it could never roll, like it could never roll through that. That's maybe not the best analogy, but it would, yeah, it can never actually touch that space, right? Because you punch the space out, it doesn't exist. Let me think of, there's a better analogy. That's what I'm actually trying to do as I'm talking. I'm trying to think of, there's maybe a better, more physical example that maybe a product that kind of shows that.
Got another question.
Sure.
Maybe you said it already. Why do we only use 3 0 predictions set? How do we know the goals? We had 2 answers at the top.
But the second insert, the both the top and the bottom. So physically, so what I'm saying is like, in some sense, I think you're overthinking. So you're trying to be like, I see these numbers, so I do this thing. But what I'm saying is this is a visual. Since these overlap, that means -1 makes the top and the bottom 0. Means it's this third. So the third scenario is visually what makes the top and bottom. If we're right back, we will I mean, but do you see visually that I have a 0 on the top and the bottom? That's the calculation. I have a 0 on the top and the bottom. There's these -1s make it 0. So physically, like, I'm just saying the picture matches. That's a 0, that's.
Don't want it to be.
Yes.
Things
Yes. Question. That's. So if the visual doesn't work, it's well for none of them, I'm just saying for you, for anybody, then like you said, yeah, the ones that we're gonna choose, that's gonna be the one. What else?
How would you draw anything?
So yeah, let's talk about it. So not just that, so let's start putting the rest of this graph together. So based off of all this is actually kind of what I. So first off, like I said, the graph naturally splits into the left side and the right side. So on the left side, we actually have 2 points, which is gonna be enough to get the picture of the left side. So what do you guys see on the left side? What should this graph look like?
And go below the 1/2.
Good, so it can't go below the 1/2, it can't even meet the 1/2, so it's gonna get closer and closer to that line, but never touch it. And where else can it go?
I can't go to the drag.
Yeah. Yeah, they're both 1/2. So yeah, it can't go to the right past that vertical asymptote,
But it touched the lines.
but it's gonna touch the line intersect, and the line is gonna go, it's gonna act like it's gonna go through this point, but does not go through it.
So what this means then is, so you wanna treat this. You wanna treat this sort of like it's a point. So the graph is gonna go from there down to where my horizontal asymptote without touching it. I can't put any ink here because it doesn't actually reach that point. But I can start right after it and then just draw up through there. So my graph is. And again, a graph is something to communicate to a reader, right? So that's why I'm like stopping here and starting. Really, it's this infinitesimally small place that just doesn't, but we can't draw that. With the marker or a CAD, computer, CAD, printer, whatever. So we use the circle to show that. Then my challenge to you guys is on the right, surprisingly, this one point is enough. What do you guys think on the right? And if you don't see it, then we'll do another point. So it's never harm to add an extra point.
Unless they're just down. Yeah, go past them.
So since the fact that this is below that horizontal asymptote kind of already tells me that this side of the graph is gonna be below, it's gonna be down. But otherwise, it's the same 2 bits of logic that going out to the right, I can't get at or above that 1/2 line, and going to the left, I can get at or above that vertical asymptote. 1/2. So this is also gonna be something roughly like this. Yeah, that's not right. So the point of doing that, all that first, at least if it makes sense, if you saw that, if you just saw that and you were like, actually, that's pretty freaking cool. The point of doing that, all that first is you shouldn't need many points after this. In fact, on this one, we didn't need any other points. Usually you still maybe need 1 or 2 other, X values and, but that's about it. And you'll have the whole graph. Yes. But you need the asymptotes. The asymptotes are absolutely huge on this. So the vertical, I would honestly say the vertical asymptotes and the horizontal asymptotes are actually the most important things to get if you're going to set up the graph. Because that allows you to say it goes down this way, never touches, and it goes up this way. Yeah. All right. Any questions there? Yeah. Yeah.
I was. I get those answers that have infinities, I think it's U between.
Well, honestly, so we can talk about domain and range. So part of what I do is I go through a class. Honestly, because we've done domain and range before, I was not going to talk about it. And it's not to be meaty y'all, but it's if you've done domain and range in the first 3 weeks of class, you actually should be able to get domain and range without any further so we can talk about it, but I do want to set that as like that is an expectation going further. So we're after this test next week, we're going to look at a whole nother set of functions, and I may ask you about domain and range, but I'm not going to teach you how to do domain and range with them because it's the same. So the thing is, I want you to expect that it's the same. If we've learned a topic, you don't need to relearn it for the new thing. Yeah.
It's really just, I don't understand.
The U is, so when you have the intervals that we have for, that we usually get for domain and range, they're sets technically, and the U is a way to stick 2 sets together. It's like a column, basically. So like when you give 2 answers and put a column between them, the U is literally just a comma for sets for intervals.
So like, with this problem here being an example of that, like the domain It would be demonstrated to little lines
Well,
on each of those sides, because that's what was confusing me, is that there's two of the squares. But
okay, so let's look at the domain on this. So the domain, I'm gonna try to list all the X value, basically all the X values that are covered from the vector. And like we've seen in previous stuff, so there's two things that are occurring here that are affecting our domain. So normally our domain is usually negative infinity to infinity. If you look at this picture, that's kind of what it looks like, because it keeps going left and it keeps going. Right. However, there's an open circle, so we never touch that X value. And there's also a vertical asymptote, we never touch that. So there's two different X values that we never touch. So let's just kind of note those. So we never touch what this was -1, and we never touch 1. My domain then is going to reflect that. So I basically, this domain is going to end up having 3 parts. We're going to have the domain, we're going to have everything up to the -1. And then we're going to have everything between the -1 and the 1/2, and then everything from 1/2 later. So does that make sense visually? But what that does tell me is my domain then is gonna be 3 pieces. And I stick the pieces together within. So let's look at the left piece. So what's my domain of everything up to this open circle? Infinity to -1. And it never reaches the -1, so we'll put a parenthesis there. And then there's this part of the graph where you're going from the -1, up to this vertical asymptote. What's the domain of that part of it? Well, the infinity though is a y value. So domain is just talking about X values. So the y value is going to infinity, but what X value is it getting close to?
Oh, 1/2.
1/2. So there's a second part to this domain that is negative or -1, positive 1/2, but never reaches the -1, never reaches the 1/2. And then you're just auto sticking U there. So U just with sets, it's the same as a column. So because these are sets, though, you cannot put a comma there because the comma does not use sets.
But for this graph, you would do that for that one, and the bottom one too.
Yeah, so
The domain.
what I'm saying, it's not this graph. So we had a
Yeah.
couple, there was a couple the second week that were like this. So it's not just this graph. Anytime you have multiple intervals that make up your domain or range, you have to put in U pieces. Because the pieces are sets and sets get used between them, not common.
Right.
Yeah, so that's what I'm saying though, is, yeah.
If I was to do the domain for the bottom, where I put a U,
You put me,
that's
Yeah,
set,
sorry.
so that would be like over, like 3
yeah, it would be, well, it's gonna end up being 2 U's, but yeah, your idea is correct. Yeah. So I'm gonna have another part to this. So I'm gonna need a U, and then what's the domain of this part?
1/2.
Yeah, so that's 1/2
Infinity.
to infinity. So 1/2.
Okay, so that makes,
Sure. Good. So let's do, I'll give you guys a second to do the range, and the range you're gonna run into a similar issue. So range, we're talking about how far down and how far up. But there's, well, yeah, at least on this graph, we know that we never hit the y value of 1/2. We also don't hit this y value here. So we're gonna end up with a similar thing where if you're thinking about the range, there's a bottom portion, the middle portion, and the top portion, and you need to give the range for all 3 parts. So actually, so I'll give you guys a couple minutes this week to put together the. So what do y'all get?
We did one half. 40-30. I was doing the one.
You were kind of doing the middle, yeah, so there is sort of this weird, there's this weird middle portion that I think is weird because visually you don't see it well on the graph. But yeah, so kind of starting from, in some sense, starting from here, you have this portion where you never quite get down to one half, but starting at one half and getting up to the y value there, 4/3, but you never reach that. Well, there is, just because I already sort of see the answer in my head, that's gonna be sort of the middle. Yeah, 1/4. But then there's still gonna be the rest of that curve going up, and there's also gonna be the range of this whole curve on the bottom. So let's start with the bottom. What's the range of this piece on the bottom? So good, we top out, or we get closer and closer to 1/2 on the top, and then we go down to negative infinity. So that's gonna be negative infinity to 1/2. Stick a U between them. Negative infinity to 1/2. And then continuing up the graph, 1/2 to 4/3. And then the third part, what's gonna be after? 4/3 to what? Okay, that's positive infinity. So union 4/3 to infinity. That'll be your switch.
Does it matter the order thing?
I think it'll matter for the homework, but for me and in reality, no, it doesn't matter.
For the middle one, we looked at the horizontal and.
You looked at the horizontal after put it in the hole, yeah. All right, any other questions on domain range there, so. This was good to bring up, so despite me thinking the same that, yes, be able to do it, this was still some really good things. So with that, we're not gonna have time to get through a whole nother problem, which is fine. But like I said, just be easy on yourself, and nature of these problems, they are long, they're putting together a lot of skills and pieces. To one kind of problem, so that is by nature just harder, so it just means you gotta go slower, think more through it. And then honestly, so you have till Sunday night to finish this homework, do it and be done, let it go. And then next week, we're gonna come back for the test, so we'll review on Tuesday, maybe test on Thursday. So I will see you guys on Tuesday, but enjoy the weekend. Okay. Yeah, so is it 0 tablets on? Cause I changed the 0. Just a second. Cause I changed and that's still shit. From back to 0.
Yeah, I think certainly the my policies having a problem, because there was another time where
Yeah,
you deleted, or you took something off and then it just turned
and then
into.
it just turned it back. All right, well, I mean,
Just look at it.
yeah.
So, but we weren't supposed to do a review on Alex, were we?
Yeah, you weren't supposed to. So
That's
yeah, but did you start did you accidentally start the review on Alex? Because it wasn't just, there were several people who accidentally started, and that might be what's causing it.
I don't
Maybe
believe
not.
so, because I
Okay.
never knew there was,
Yeah, okay.
to my knowledge.
No, that's good. All right, let me look at what's happening with this.
I'm actually gonna go to the map world today,
Okay, sweet.
because I'm still kind of rough on the multiplicity from last subject,
Mm-hmm.
from last week. So
Okay.
there's just a few things.
Yeah.
I'm gonna go Plus I need to do hours. I've done any.
True.
And then they can help you more too.
Yeah, yeah.
Last name Bark.
Yeah, so I mean, I see the 0 here. However, let me make sure I'm right about this, but so there is a 0 here, but I'll show you. Pretty sure this is the way it's. Um, so like I said, the percentage, or the groups that each of these assignments are in. So let me make sure. Yeah, so this review is in this group that has 0% of your total grade. So it's not actually affecting your grade because I set the weight of it to 0%. Yeah. So that's why I haven't gone through and changed it actually, is like I just know that it's not actually affecting your grade. Yeah.
Oh.
Yeah. So yeah, no worries.
I just had a problem in my other class where there was something really old and the whole time it was affecting me. But I never knew and the teacher never knew.
And then yeah.
And it was like an imported assignment and then he changed it.
Yeah.
He deleted it and then it converted itself into a 0 for 2 things on the quiz. Like it never existed, but then it
But
did,
then,
and
yeah.
it was hurting
No,
my grade.
I've had that
So now I'm
happen.
a little
I've had that happen in a class before actually, which is honestly, that is why I've started turning the imported assignments into a 0%, because then you don't have to mess with any of that. Because whatever is in there, it multiplies by 0, and so it doesn't add to your grade.
Yeah.
Yeah.
The whole time I was in the quiz, because this was my flex 1. The whole time, no matter how well I would do,
Yeah.
my grade never went up.
Yeah.
Because that was
Because
weighing 200 points.
Damn.
Were weighing me down.
Yeah.
So, I didn't notice it until like the 7th out of 8th week. So
Yeah.
I was glad that I did because
Yeah.
I never would have gotten it.
True.
So now I'm a little obsessive.
No, understand.
It's the technology.
Well, I mean, that's always my thing too, though, is like that's why you always gotta game. You always gotta critically think. No matter what they make on this, it's like no matter what logical system you make, you end up with weird things like that. So my thing is like, as the user, you just always got to be able to game around it.
Yeah.
Yeah, double check things. True. Yeah.
January 24th.
Yeah.
Didn't the semester start like 3 days before?
But basically, I was gonna say, yeah, basically started 3 days before that. Yeah.
He had us so many assignments that you have to scroll and scroll. And
Yeah.
scroll and scroll. So it's so easy to just
Miss something. Yeah. Yeah.
But- trying to play with the what. He did an extra credit assignment, so
Yeah.
I had an 89 for like 5 weeks, maybe 6. So I
Yeah.
was really wanting the A, so I'm playing with stuff. And so someone taught me how to scroll all the way down, and there's all these categories.
Yeah.
For, this is your total percent for all your quizzes, your exams,
Yeah.
whatever.
Yeah.
So then I changed the layout of my grades to based on assignments. So a homework chunk block here.
Yeah.
Quiz
Yeah.
block. So
True.
that's how I noticed it was when I did that.
And you were like,
It totally just scrolled past it, and it wasn't even like, it was January, but it was mixed way in at the bottom.
Yeah.
Like, it didn't make any sense.
yeah.
I just happened.
well, and that's another thing with Canvas, some of their programming, the way that you enter the assignment, sometimes the date doesn't determine where it is in the list. And I haven't figured out what the other thing is that it's using, like the scheme it's using to order it. But that is a problem. That's a problem that I run into where I'm like, it's like I need to see that at the top of the page, or my students need to see that on the left end of the grade book. Why is this all the way over here? Like that doesn't make any sense. Yeah.
It was like a duplicated test,
Yeah.
and it was for like our lecture exams 1 and 2, and it
Yeah.
was just a duplicate. And it was weird because you'd be on dashboard and it would say you had 2 tests or 2 this, and it was
Yeah.
just.
Okay.
And then the factoring that this guy had us use a lockdown browser.
Yeah. Yeah.
External software, like how we have Alex, that, plus
Yeah.
you're taking quizzes on campus.
Yeah. Yeah.
Now my new teacher.
Yeah.
I hope to get more
That's-
sleep now.
Well,
and it's a lot easier.
like when I do remote and online classes, I never use Respond as Monitor because that, like you said, it's another layer, it's another program, another layer. And also like it doesn't actually, if somebody wants to cheat, there's nothing about that video that I'm gonna watch that's gonna tell me yay or nay, right? Like so it's like if people really want to do the thing, they're gonna do the thing. So what I do is I have my students come in live on Zoom, basically. And that actually works really well because then everything they're doing besides the Zoom link, everything they're doing is in Canvas anyways. So you don't have a third thing to mess with. And there's also the psychology of it. When somebody's watching you live, people just tend to cheat less. There's just, so yeah, so I get very little cheating with it, but more importantly, like it works so much better than doing that stupid ass Respond as Monitor.
Talk
Yeah, exactly.
or flags your time.
Yeah, yeah. And it's like, well, because especially I'm one of those people that when I'm thinking about stuff, my eyes are moving all over the place. So I just think about like if there's one of me sitting there, it's gonna flag them. But like, dude is just thinking like they're just or yeah, I'm gonna look off camera not because I'm looking at somebody or I'm looking at a website, but because like I can't fucking just stare straight for 2 hours. Like that's crazy, So yeah, I just thought through it. I was like, there's so many things that they could be doing that this doesn't actually really tell me anything about cheating or not, which makes it useless. So
Some professor said he is required to do at least one thing with lockdown browser, but he's gonna set it up to where it's screen recording and we're not using the external webcam. So we had to use the external webcam
yeah,
on a tripod on the side of you.
yeah,
And you have to take a picture of yourself, twist it all around to show your environment.
yeah.
And I would treat it like I got pulled over by the police.
Exactly, like,
hands on the
Hands on the steering wheel. Here's my ID, sir. Yeah,
That's
exactly. Yeah, yeah, it does. And
I don't. What if I fidget with my hand and they think I have something in my hand?
And anxiety is the biggest killer for test grades. It's like
Yeah.
when you have anxiety, you do a lot worse. So yeah, there's just so many reasons why like it is such a bad setup for having people take tests. Yeah.
And it was for everyone.
Yeah.
This guy,
Yeah, yeah. Yeah.
because I have to.
Yeah.
And he's giving us reviews. The other guy did not give us a review, and he gave us basically like textbook generated tests, and they would come up with the most outrageous questions possible that are meant to trick you, and he admitted that.
Absolutely. This is why I have never done a textbook generated test.
Thank you.
Because that's exactly what happens. And I know the algorithms behind it. So I even know mathematically why you end up with these oddball problems. But because I know that, I'm like, I'm not, yeah, like this machine is an idiot. I can make a much better test. I just need 4 hours to think through it and I can make a much better test that,
It's much
yeah.
appreciated.
Yeah.
He makes a test himself, and then he makes a review based on what he just put on the test.
Yeah.
And Annie is allowing us to turn in this review for 5 points extra.
Mm.
I have no excuse not to get an A, but kind of thankful that I did have such a hardcore first one because
Yeah.
now it's instilled this work ethic and
True.
kind of now I won't be lazy
Yeah. Yeah.
or procrastinate.
Yeah.
Because I'm so used to every day,
Yeah.
and it being so intense that now that I have someone more relaxed, I'm like, okay, I can use this a lot more to my advantage.
True. Yeah.
Plus, there's only 5 of us in the class on this one.
Wow.
Yeah, half my class, more than half dropped out of the last one.
Yeah.
So now there's only 5 of us to start with this.
Yeah.
But it's nice because we can do it campfire style. Like last night, we were learning the lab. We can all just pass the model instead
Yeah.
of 20 people trying to understand the same thing.
True. Yeah.
So sometimes a smaller class is nicer. Like today, we didn't have a lot of people.
I mean,
Some people talking, it's hard for, I don't sit over here because I
Yeah.
tried to one day and they just talk.
yeah.
And I've been their age, I know whatever,
Yeah.
but I need to be.
Yeah. Yeah. True.
Be
Yeah.
engaged.
Yeah.
It's a lot easier when it's quieter, less.
Yeah.
I don't mind. I didn't want to come today. It's raining and suddenly, but I
Yeah.
know I have to. And I'm always glad that I do. Adulting sucks.
Well, yeah. Well, I was gonna say, and for my class, it's always funny to me. Is like I always tell myself that it sucks that I'm from Florida because in Florida it rains every day, and so like I don't take a break for rain, like, and I don't even apologize for it. It's like, dude, like not, but it's like just drive 5 miles per hour slower. You're gonna be good. Like you're not gonna get in a wreck. Like so you have to go on with life. You have to handle life.
Yeah.
Like because it's not just rain. It's like because if it's rain, then it's this and it's that. And that's what I've noticed here in San Antonio, generally, especially Southern Texas, is like everything is a reason not to like go into work or go into school. And it's like you're just never gonna get any shit done in life. Like you're never gonna move forward. Like yeah. Exactly, yeah. So us crazy Floridians, I mean, we barely get off the road for a hurricane, honestly. So it's like, like so we're just like whatever, like that's right. Yeah, yeah, I did, yeah. Yeah. Yep. As long as I'm driving away from it, we're good. Yeah. So yeah. That's what like the last hurricane that came around and like, on the media here, they were like, why, everybody needs to evacuate and like and I'm like, no, you don't understand. Like if everybody evacuates, everybody's just gonna be sitting on a highway. Yeah, you were okay, you were there, yeah. So now we're stuck on a highway with a hurricane passing over, or you could be stuck in a structure, or you could be laying in a ditch, right? So it's like, which is the better option? Yeah, yeah,
Purges the grocery stores, but then you lose power. So you lose all the food that you just spent $300
exactly.
trying to take the last water on the shelf.
Yeah,
And then you have no way to
true.
preserve it. And so people, they just act crazy. They just act crazy. But if you're smart, then okay, I need some flashlights.
Yeah,
Maybe I need some food that don't need electricity.
yeah, yeah, basically, yeah.
I mean, part of my roof came off,
Oh yeah,
whatever, but I was still blessed, like
Yeah.
outside the
yeah.
trees down here.
Wow,
But
yeah,
I wasn't gonna leave because where am I gonna go? It even hit way off the coast of North Carolina. Like those people,
yeah.
what
Well,
can you do?
and that's what some of the people that I knew on the west coast of Florida, I mean, that's what ended up happening is even if they were able to get down the road to whatever the shelter was, then the shelter's power went out. And it was like, so we're in the same situation, like, and maybe the shelter is a better structure. So that's the only advantage you got out of it. So which is legit. But at the same time, it's like now you're sitting there crowded with a bunch of other people. Or you could be propped up in your bathtub with a live wire out there. I mean, but propped up in your bathtub with whatever snacks you got and just wait it out. It's like, yeah.
That's why most people like.
Yeah, true. What is it? Put ice in the washer and then throw some beer in there and then like you're good for a couple days. Like, yeah, true. Yeah, true, true. All right, man. Yep, yep. See you Tuesday. Yeah. It feels like a Wednesday today. I don't know why, but yeah, yeah. All right, man. Have a good weekend. See you.